Okay, so this video we're going to look at expected value and probabilities from tables. In this first example, I'm told that the probability of Bobby winning a game of chess is 0.9. If Bobby plays 150 games of chess, how many times would you expect him to win? Now this is an expected outcome question. Now the way we handle these is if we take the probability, we multiply it by the number of times that probability could occur, in this case 150, we get roughly an estimate of how many times we expect that to happen. So in this case, our probability is 0.9. We need to multiply it by the 150, and we get 135. So we would expect Bobby to win 135 times. Okay, so pause the video, read the question carefully, okay, and then answer this practice question below. Okay, so if you read the question carefully, you will notice that the probability is 0.12, and it's 300 pots that are being fired in this kiln. So we're going to multiply those two together, but I've highlighted this word here, not. Okay, because actually what we want is the opposite answer. So we can start off by finding how many would break, which is 0.12 multiplied by 300, which is 36. So that's how many we would expect to be cracked, but the question's asking us very sneakily, how many would we not expect to be cracked? So we're going to do 300, take away 36, and that would give us 264. Okay, so here's a typical probability from a table question. So here we've got a four-colored spinner, and it's spun with the following probabilities. Okay, so a red, you've got a probability of 0.2, a blue is 0.3, and a green is 0.4. But we don't know what the pink is, and it's asked us what the probability of the spinner landing on pink is. Okay, so the thing that you need to know here is that these are all the different possible outcomes that could happen from this spinner. And we should know that all probabilities add up to 1. So in this case, we need to find out what this pink value is so that all of those four numbers would add up to 1. So to do this, we're going to first add up 0.2 plus 0.3 plus 0.4. Okay, in doing this, we get 0.9. So the pink must be 1 minus 0.9, which is 0.1. Now we're asked a very similar question to what we had in the first example. Okay, so the spinner is spun 400 times. How many times would you expect the spinner to land on a red? Well, the probability of a red is 0.2. Okay, we're spinning it 400 times. So 0.2 times 400 is 80. Okay, so here's a question for you to practice with. Okay, pause the video again and see if you can answer this one. Okay, so here a four-colored spinner is spun again with the following probabilities, and this time we don't know what green or pink is. But it is told in the question that the probability of it landing on a green is the same as it is landing on a pink. So what's the probability of the spinner landing on a pink this time? Well, again, we need to find out what these two values are that are going to add up to 1. So we've got 0.2 and 0.3. Okay, which add up to 0.5. So I know that green and pink must add up to 0.5, and I know that they're the same, so all I'm going to do is divide it by 2. And dividing 0.5 by 2, I get 0.25. So the probability of it landing on a pink, as well as landing on a green, is 0.25. Now the question down below, the spinner is spun 120 times. How many times would you expect the spinner to land on a green? Well, we've just found out that a green is 0.25 and it's being spun 120 times. So we multiply it by 120 and we get the answer of 30. Okay, so hopefully this has helped you to answer these sorts of questions. Again, practice exam questions on this and good luck.